Introduction. Rita, I have placed immersion rod and bucket to heat water. Do not go near it.
I wanted to ask you about this. How can electricity heat water or cook food, such as in an electric cooker that you use to cook rice?
This is all because of heating effect of electricity. Let me explain you this. Children, in this lesson, you will learn about electric current, electric circuits, and effects of electric current. Objectives. At the end of this lesson, you will be able to define electric current and circuit, identify the potential and potential difference, describe the circuit diagram, explain Ohm's law, identify the factors on which the resistance of a conductor depends, describe the resistance of a system of resistors, explain the heating effect of electric current and electric power. Electric current and circuit. All things around us are made up of atoms. Each has three particles: protons, neutrons, and electrons. Electrons spin around the center of the atom and have a negative charge. Protons are in the center of atoms and have a positive charge. An electric current is created when electrons move through a conductor. There are two types of currents: direct current, DC. A current that flows in one direction is called a direct current or DC. For example, a battery produces a direct current. Alternating current or AC. A current that flows back and forth is called an alternating current or AC. The symbol of electric current is I. Electric potential and potential difference. Let us look at the concepts of electric potential and potential difference. Electric potential. Electric potential is a scalar quantity denoted by E or V. It is a point equal to the electric potential energy of a charged particle at the location divided by the charge of the particle. Electrical potential difference. Electrical potential difference determines the direction of the flow of charge. For example, consider a pipe connected to a container through a stop cork. The quantity of water in the pipe is less than the quantity in the container. However, the level of water is higher in the pipe than the level in the container. When the stop cork is opened, the water begins to flow from the pipe to the container till the levels of water in both the pipe and the container are equal. This determines that it is not the quantity of water but the level of water which decides the direction of flow of water. It is the potential difference that is responsible for the flow of water. Did you know? The I symbol was used by André Marie Ampère. The unit of electric current is named after him when he formulated the eponymous Ampere's first law discovered in 1820. Circuit diagram. A schematic diagram is easy to represent an electric circuit. There are conventional symbols that you can use to represent most of the elements used in the circuit diagram. The symbols are shown. Ohm's law. Ohm's law deals with the relationship between voltage and current. It states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. Factors on which the resistance of a conductor depends. There are three external factors that influence the resistance in a conductor. They are thickness, length, temperature. There is a fourth factor that influences the resistance, and that is the conductivity of the material. This, however, is considered an internal factor rather than an external one. Thickness. The cross-section area of a conductor or thickness can be compared to the cross-section of a hallway. If the hall is wide, it allows a high current through it. In case of a narrow hall, it would be difficult for the current to get through. This is due to the cross-sectional area that restricts the high rate of flow. Length. The length of a conductor is similar to the length of the hallway. A shorter hallway allows movement at a higher rate than a longer one. Temperature. The temperature of a conductor does not have less effect on the resistance of the conductor. The higher the temperature, the higher is the resistance. For example, when you turn on a light bulb at the first instance, the wire is cold and has a low resistance. But as the wire heats up, it gives off light and increases the resistance. Did you know? When you double the length of a wire, you double the resistance of the wire. Whereas when you double the cross-sectional area of a wire, you cut the resistance in half. Resistance of a system of resistors. A resistor is known as a passive two-terminal electrical component that represents the electrical resistance as a circuit element. The current passing through a resistor is directly proportional to the voltage across the resistor's terminals. Thus, resistance is the ratio of the voltage applied across a resistor's terminals to the intensity of current through the circuit.
Combination of resistors. Combination of resistors are of two types.
They are resistors in series and resistors in parallel. Resistors in series. Resistors that are connected in series, where the current flows through them one after another, are known as resistors in series. Here, the current depends on the applied voltage, the number of components, and the nature of components in the circuit. Resistors in parallel. Resistors that are connected such that they branch out from a single point and join up again somewhere else in the circuit are known as resistors in parallel. Here the current through each component is the same as if it were the only component present. So the total current flowing through the battery is the sum of the currents flowing through each branch. Did you know? For resistors in series, the current is the same for each resistor, whereas the resistors in parallel, the voltage is the same for each one. Heating effect of electric current. The heating effect of electric current is widely used today. This effect is caused when electric current is passed through a conductor. This generates heat due to the resistance it offers to the current flow. The work done in overcoming this resistance produces heat. The heat produced by a heating element is directly proportional to the square of the electric current passing through the conductor, the resistance of the conductor, the time for which current passes through the conductor. It is defined as H is equal to L2RT and is known as Joule's law. Practical applications of Joule's law. The heating effect of electric current can be applied to many appliances. These include electric immersion water heater, electric iron box. A good heating element has a high resistivity and a high melting point. For example, an electric fuse is an example of heating effect of electric current. The rating given as 3A of an electric fuse states that the maximum current it can sustain is 3 ampere. Electric power. Electric power is the rate at which electric charge is transferred by an electric circuit. This is commonly known as electric power. The following are the components associated with electric power. The International System of Units, SI, defines the unit of electric power is watt, W. It is known as the power consumed by a device that carries 1 A of current when used at a potential difference of 1 V. Watt is very small unit. In actual practice, a much larger unit called kilowatt is used. This unit is equal to 1000 watts. The unit of electric energy is watt hour, WH, as electrical energy is the product of power and time. The commercial unit of electric energy is kilowatt hour, kWh, commonly known as unit. Did you know? Electric current is also used in nature. Natural examples include lightning, the solar wind, and the sources of the polar auroras. Summary. Let us summarize what we have learned. An electric current is created when electrons move through a conductor. A current that flows in one direction is called a direct current. A current that flows back and forth is called an alternating current. Electric potential is a point equal to the electric potential energy of a charged particle at the location divided by the charge of the particle. Electric potential difference determines the direction of the flow of charge. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. Three external factors influence the resistance in a conductor: thickness, length, and temperature. A resistor is known as a passive two-terminal electric component that represents the electrical resistance as a circuit element. Resistors that are connected in series, where the current flows through them one after another, are known as resistors in series. Resistors that are connected such that they branch out from a single point and join up again somewhere else in the circuit are known as resistors in parallel. Electric power is the rate at which electric charge is transferred by an electric circuit.